Hey mathematicians, this is our guided practice for multiplying using arrays and area models. Jane's bedroom is 15 feet long and 12 feet wide. She draws the area model to represent the floor of the room. Which equation represents the product shown in Jane's model? So I am going to first combine my factors here. So 10 plus 5, that would give me 15. 10 plus 2 would give me 12. So I know I'm multiplying 15 times 12, but now I need to figure out what my product is when I multiply those factors together. So remember our base 10 models, right? This would be a flat. So this is going to represent 100. Each rod is going to represent a 10. And each unit is going to represent a 1. So now we just need to total those up. So 100 plus 10, 20, 30, 40, 50, 60, 70 of 7 tens for a total of 70. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units for a total of 10. And that would be 100 plus 70 plus 10 for a total of 180. So A is not going to be correct because what they're doing is they're combining this 10 and 5. They're just rewriting the number like that. And we need to make sure that we're adding them together. So it's not going to be A. B, 12 times 15 equals 180. That's a maybe. 12 times 12 equals 144. While that multiplication problem is correct, it doesn't represent Jane's model. So we're going to eliminate C. And 15 times 12 equals 110. Does not equal 110, it equals 180. So it looks like B is our correct answer choice. Casey reads 21 pages every night. Which model shows a way Casey could use base 10 blocks to find the total number of pages she reads in 24 days? So I need 21 times 24. So 21 times 24. If I break these apart into base 10s, I'm going to have 2 10s. So 10 plus 10, 1, 1. Then I'm going to multiply that by another 2 10s. So 10 plus 10 plus 4 1s. So going up to my answer choice, I need to have a 10, a 10, a 1, okay. Then I have 1 10 and then 1, 2, 3, 4. So doesn't look like that one's going to work. Let's look at G. So I have 10, 10, 1, 10, 10, 1, 2, 3, 4. So that might work. 10, 10, 1, 10, 10, 4. So that's a maybe. H, I have 10 and 1, and then 10, 10, 1, 2, 3, 4. So I have this second part of the equation, but the first part was not finished. And J, I have 10, 10, 1, 2, 3, 4, 10, 10, 1, 2. So instead of this 1, it's a 2. So J is not going to be correct either, making G our correct answer choice. All right, last one. The windows on the front of an office building form an array that is a perfect square. The model represents the top row of windows. Which method could be used to find the total number of windows on the office building, on front of the office building? So we need to have a knowledge of what a square is, right? A square means that all sides are equal. So we need to first figure out how many windows there are in our top row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 windows. So what I know about this building is it's going to be the same on all sides. So if there's 14 windows up top, that means there's also 14 windows going down. It's going to form a perfect square. So 1, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, we'll pretend that fits on the page. So there's 14 going across and 14 going down. Now we need to figure out what equation is going to represent this perfect square. All right, so my building looks like this. I have 14 windows going across, 14 windows going down. So I'm going to have 14 and 14. Knowing what I know about area models, I'm going to multiply those two together. So 14 times 14 to find my answer. So let's look at our answer choices. F, find the product of 1 and 14. 1 times 14 equals 14. Well, that would be right if I'm just looking at this top row, but it wants me to find the total number for the entire office building. So that's not going to be correct. Double 14, 2 times 14. Well, if I doubled 14, I would only be looking at these top two rows, right? And it wants me to look at the entire building. So I'm going to eliminate G. Find the product of 14 and 14. So 14 times 14 equals 196. That's what we have. So we're going to mark H as a maybe. J, find the sum of 14 and 14. So 14 plus 14 equals 28. We are not looking for a sum. We are looking for a product. We're multiplying. So we're going to eliminate J, leaving H is our correct answer.